This will be your first set of notes for the year for Algebra 1. In section 1.1, we're mostly going over some definitions for terms that are important, along with reviewing some procedures. So first, we're going to start off with what is a variable. Now, a variable is simply just a letter used to represent an unknown quantity. You've probably used X most often to represent a variable, but we can pretty much use any letter of our choosing. Next, we have something called an algebraic expression, or maybe called a variable expression. And this is a quantity that contains at least one variable. So, for example, we might have 2x plus 3. Y itself is an algebraic expression. A plus B plus C is an algebraic expression. So again, anything that represents a quantity but contains at least one variable. Notice an expression does not have an equal sign. If we had an equal sign, it would make it an equation. So expressions themselves do not contain an equal symbol. Next, we have the word evaluate. And in math, this most often means to substitute a number for a variable and simplify. So, for example, I might say evaluate an expression when a variable equals a specific number. So in this case, the expression 2n plus 3, if I'm evaluating the expression when n equals 3, then I would replace n with 3, or substitute, and simplify. So 2 times 3 is 6. 6 plus 3, and the expression is 9. All right. So I was not able to evaluate that algebraic expression until I had a value for the variable. And in the second example, the expression is 2n squared. So again, replacing n with the number 3 and simplifying. So I must square 3 first, and 3 squared is 9. So 2 times 9 tells us that that quantity equals 18 when n equals 3. Next, we have the word power, which we may also use the word exponent to express the meaning. And this is an expression that represents repeated multiplication of the same factor. So in our example, this is read as 5 to the third power. So the number 3 is the power or the exponent itself. And as you can see, we rewrite 5 to the third power as 3 factors of 5. Remember, a factor is a number used for multiplication. So 3 factors of 5. And the result, when simplified, would be 125. So in this first example, where we're writing the power in words and as a product, we would say 8 to the third power or we could say 8 cubed, and it would be written as 3 factors of 8. So when I say write as a product, this is exactly what I mean, since I'm multiplying those quantities. And then in our second example, we could read this as x to the second power, or we could also say x squared. And written as a product, that would look like this, where it is 2 factors of x. Next, we need to review the order of operations. Now, in the past, you've probably used the acronym PEMDAS to help you remember in what order you simplify an expression. So that is the D right there. So the only difference I choose is instead of a P, I actually use a G. And the reason for that is this P stands for parentheses, since parentheses are a grouping symbol. However, it is not the only type of grouping symbol. So whenever you have a grouping symbol within a mathematical expression, that needs to be performed first. So you do have parentheses, but you could also have brackets, braces, a radical symbol. This is a fraction bar, which refers to division, but what happens is it actually groups the numerator quantity and the denominator quantity. So that's why I choose to use a G. Anything within grouping symbols would occur first. So the next operation that must be simplified are exponents, or as we just stated, we could say powers. So for example, if we go back up to this expression, notice we simplified 3 squared before multiplying by 2, because exponents must be simplified before multiplication and division, which is what comes next. So multiplication, and I've actually put these letters on the same line because they can occur in either order. Now, we generally evaluate them from left to right, but again, they could occur in either order. And then lastly, we have addition and subtraction. So those also could occur in either order, but we generally evaluate from left to right. And I'll make that note over here. So just as you read a sentence, sometimes we simplify a mathematical expression from left to right. So for example, I might say, if I had the expression 5 minus 3 plus 2, I would actually perform the subtraction first. So 5 minus 3 is 2, and then I would add it to the final 2 to get 4. This will apply to numerical expressions, so just expressions involving numbers only, but it can also apply to algebraic expressions as well, meaning those involving variables. So looking at some examples, if we were to simplify this first expression using order of operations, notice I said earlier that this fraction bar is a grouping symbol, so I'd have to simplify everything in the numerator before dividing by 50. So I have 3 times 25 plus 5 squared, which is also 25. And then 3 times 25 is 75. So I performed the multiplication. Now, you might be thinking, well, don't we perform division before addition? But again, this grouping symbol forces me to add these two numbers together first. So this becomes 100 divided by 50. So the final value is 2. And in the second example, we actually have two sets of grouping symbols. So the innermost one occurs first. So 9 minus 5 will get simplified, which is 4. And then since the exponent is inside of the grouping symbol, that gets simplified next. So 8 times 20 minus 4 squared is 16. So now we must subtract 16 from 20. So 8 times 4, leaving our final result at 32. And if you were to type this expression into your calculator exactly as is, you would and should get the same result. Next, we have a few more examples of evaluating expressions. So our algebraic expression is 6y squared minus 13, and we're evaluating it for when y equals 11. So 6 times, I'll use a different color, 11 squared minus 13. So we must square the 11 first. So that's 121. And 6 times 121 is 726 minus 13, leaving us with a final value of 713. In the second example, we're evaluating this expression when b equals 3. Notice the variable b shows up two different times in our expression, so we must substitute both of them with the number 3. So we rewrite this as 3 cubed minus 21 divided by 5 times 3 plus 9. So I must simplify both the numerator and the denominator before dividing, since, as we said before, this fraction bar is a grouping symbol. So 3 cubed is 27, and 5 times 3 is 15. And I can subtract up top and add on the bottom, and I get 6 divided by 24. Now I could divide those two numbers, and notice I should get a number less than 1 since my numerator is smaller than the denominator. So I could write this as a decimal value, or I could just simplify the fraction and put it in simplest terms, making it 1/4. In this next section where I ask you to try, I do ask that you pause the video and try both of these yourself before looking at the answer. This is going to give you the practice, and it's your first chance at trying something sometimes new, sometimes review. But again, please try for yourself before reviewing your answer. So go ahead and pause now, try it, and then hit play to see what you should get.